particular in summary about WAN use cases for AI and AI use cases for the WAN. So we'll make it clear as we go through what that is. We'll start with an intro of the panelists, and we'll go through some discussion, and we'll open the remaining 5 minutes of the session to Q&A, basically for the audience. Right. So what I would like to start with is that really the connectivity problem for AI across the WAN. Traditionally, whenever we talk about AI networking, we're worried about the data center environment, how to interconnect GPUs across a fabric in the data center, across backplane, like what we call like NVLink, and things are coming about with the ultra accelerator link as an example. What we'd like to focus on today is see what is the need really in the WAN for AI applications, in particular whether it's training or inference, if you will. And the reason for that, because there is obviously people have data usually on their prem, they are bursting for training in the cloud. There are service providers coming about providing GPU as a service, which is creating kind of a market to leverage GPUs from multiple service providers for both inference and training. And that involves moving data around, probably instantiating models around. So in here, I think, Jordan, I'll start with you. I know you've announced things along like what we call the AI fabric, basically. If you want to exchange fabric, what problems do you see really in the WAN for that type of AI workloads, and how you're solving?
Thanks for that, Nabil. It's the AI Exchange, and we launched it about a month or two ago at Megaport. And what we're trying to solve for is take the customers that sit on our platform today and allow them to meet up and match and connect with other customers, other partners, CSPs, private cloud, bare metal, GPU as service providers, and allow them to have that agility, the choice. I love the term you use. There's a bit of arbitrage in there as well. And being able to go and select what compute do they need. GPUs, they can select if they need a Blackwell or an H100, or do they simply want to go to AWS and leverage a platform like Bedrock to get to Titan, or build out their own models or foundation models with something like SageMaker. And so we've built this exchange to really provide choice to our customers and flexibility, and then be able to dial up and dial down the capacity they need. Because I think a lot of customers today, for us, our enterprise customers, I don't think they don't know what they don't know at this point. They're still trying to figure it out. And we give them the ability to kind of test that out, turn the dial, add more capacity where needed, and then also figure out what are the requirements for those workloads, whether it's a training model, an inferencing instantiation, jitter, loss, delay. What does that look like? Where do they need to place those workloads? And that's really the focus of what the AI Exchange provides.
So what I'll do that we didn't do the throw as you speak. If you do.
Yeah, no worries. So Jordan Dukes, I'm Director of Strategic Solutions at Megaport. In my role, I build, design, and drive. I'm losing the mic here. Build, design, and drive new designs, new services and products as I hear them come from our customer base. For example, right now, one of those things is how to design for high-capacity AI workloads and also encryption. Line rate encryption, 150, 200 gig of encryption on demand for verticals like healthcare and fintech and finserv. And Megaport, traditionally, what we've done is focused on being able to build capacity into about 850 data centers globally. We have 280 on-ramps, and then DC to DC, cloud to DC, edge to DC, and that's really the focus of our platform.
Very good. Thanks, Jordan. Raj, any insights into that problem across the WAN about enabling your customers to move things around, if you will, whether data models or... And please start with an intro.
Sure. Thank you. So, hi everyone. My name is Raj. Full name Rajarshi Purkayastha. It's very long, very complex. Like what's happening around the whole technology area at this point of time. So I've simplified myself. My name is Raj, so you can just call me Raj. I'm from Tata Communications. We solve for the digital fabric of our customers, which has 4 different fabrics, which is network, security, cloud, IoT. Now, specifically going back to the question that you asked, Jordan, you covered a whole lot of areas, right? And that's the present perspective. I'd rather look at the future. Now, the future from an AI and from a GPU perspective, which I was discussing with Nabil and others, is that we are going to have GPUs on at the end devices, which is your phones, your laptops, your IoT devices, and so on and so forth. Which means that the network of today is going to shift dramatically to accommodate what the GPUs are going to ask in the future. And that's one area that we are working on. There are a whole lot of things that we need to develop, starting from what are the standards that needs to be used, because at this point of time, if you look at any GPU manufacturer, they're using their own standards. It's proprietary, and therefore, it's difficult for somebody like an MEF to come forward and say this is the protocol, this is a standard that you use. So starting from there to what kind of reference architecture should be there, so on and so forth. Starting from LAN to the WAN to the cloud edge, right? So that's what I wanted to add to what Jordan just mentioned.
Very good. Thank you for both. Before I move to Alwan, I think I just want to follow up a bit on a couple of things. So you mentioned what your basically mission in this case is to allow your customers to have accessibility to GPUs, either into connecting GPUs, placing workloads on GPUs, and so forth. What are the problems that you're trying to solve? Is this like a latency issue, providing bandwidth on demand, reliability? Can you talk to that a little bit, Jordan, if you will, and then
Sure.
Raj?
Maybe I'll start, and Jordan,
Yeah.
you can add.
That's fine.
So the first thing which happens is, if you look at the GPU, the network requirement of GPUs, right? It's not in megabits. It's in hundreds of terabits per se at this point of time. You're looking at you know uh, 16. You're looking at 1600 terabits and so on and so forth. On the WAN, you're not going to reach there, right? It will be either not very business case friendly, or you'll not be able to reach that kind of bandwidth from a WAN perspective. So, what is the WAN bandwidth that you should be looking for, and how do we, as service providers, give that to you? The second is when it comes to latency, when it comes to packet loss. Again, GPU to GPU communication talks about lossless and so on and so forth at this point of time. There will be some losses, but what is that? And therefore, in that, for example, you will have an edge strategy going forward, right? Edge is going to be extremely important. How edge is going to connect, where the edges will be, and so on and so forth, is what we are kind of bringing forward so that we can solve for that. High bandwidth, low latency, less packet loss, so that if you're not going to do modeling between two GPUs which are from a north-south perspective, but maybe some inferencing will happen, right, from your phone, from your laptop to the data center. In that case, what is the bandwidth which is required? What is the reference architecture for that? What kind of losses can be uh, accepted by the model, and how do we take
Very
it forward?
Well, let me. This is a good segue for Owen. Actually, well, I'll get back to you, Jordan.
Correct.
So, you are in providing cellular connectivity in a LAN environment to the users. Building on what Raj said, what problems do you see as AI application proliferate? Usually, people are interacting with it
Correct.
to get inferences and so forth. If you could start with a quick intro about who you are, what you do,
Sure.
and then address the problem, that would be great. I will come back to Jordan on that problem.
Right. Thanks, Nabil. I'm Alvin Sequeira, founder and CEO of Highway 9 Networks. What Highway 9 Networks is building private mobile clouds, essentially leveraging 5G technology to be able to bring that cellular technology in a privately owned fashion on campus. We solve issues like coverage from the three operators and covering some Wi-Fi um, uh, blind spots. But specifically to AI and the cognitive infrastructure, what we are finding down on campuses is there's a bunch of edges right on campus or even off campus in a bigger metro area, plus devices. These devices don't necessarily have to be on campus itself. It's attached to a SIM card and accessing. So devices have LLMs increasingly being built into them. Edges have LLMs being built into it. So this mix of different edges with different devices, think about them all coming together. What's the right technology for them to come together? If you're on campus, yeah, you can maybe get everyone consolidated on fiber. But if you're across a metro area and all, the only common technology that's across the campus, across a metro areas, probably some cellular technology. And so we are beginning to see lots of use cases where a lot of these edges, including the LLMs sitting on them, these edges are going to be some mix of GPUs and TPUs and x86 based architectures. These edges will carry the LLM stacks and things like that, and inferencing engines, and devices like SIM-based phones and iPads might access data and inferences from the edge. They might also themselves be leveraging LLMs on the device itself and uploading updates and things like that for LLM updating and RAGs and things like that. So we believe this cognitive infrastructure has to be built on some kind of a wireless technology that's low latency, always on, reliable, and lots of bandwidth and throughput that's committed. So 5G technology is a very good technology for bringing that. And so we are beginning to see use cases working with the NVIDIAs of the world, the Bedrocks and the Vertexes from Amazon and Google respectively, all beginning to figure out in a wireless standpoint, can I build my own private mobile cloud with low latency? And that's where the cognitive infrastructure plays a big role.
Very good. So basically, all of you hit the point that to get good customer experience, whether for training or inference, you have to have reliability, you have to meet the latency requirement, and in particular cases, you need the bandwidth requirement. If you're moving large data models around or moving data around, because eventually you have to train or you have to retrieve data that you want to bring it closer to either the inference points or the machines, if you will, that are doing the training task. Jordan, before I go to Sean, do you want to add anything to that?
Yeah, certainly appreciate it, MBL. You know, in our world, we have a global network as a service. So I need to zoom out a bit to talk about the Megaport platform and what we're doing. We're really talking about moving workloads, not only regionally or in one, on one continent. We're talking about global workloads. So wherever your enterprise users are, that's where we want to make sure that we are there. We obviously want to optimize latency, loss, jitter, and make sure that whatever it is that we're deploying, whether it's training a model, which may not be as sensitive to those parameters and performance results, but if inference is what we're trying to deploy, we can put that workload basically anywhere on the globe and make sure it's as close to those users that are hitting that inferencing workload. So it's really about, again, choice, flexibility, be able to access that bare metal compute, be able to access those CSPs. If it's Google Vertex, and as I said, Bedrock, SageMaker, Titan, whatever you're trying to get to, and again, arbitrage for the right cost point, that is what we're trying to provide to our customers with our platform.
Very good, thank you. Sean, do you want to add anything for connectivity, or we'll jump to AI ops?
I think we could jump to AI.
Okay,
Yeah.
you want to do an intro first, and then I'll pose the question.
Yeah. My name is Sean Rose. I work at Meter. We have our booth right over there if you want to learn more in depth. But we do full stack network as a service for enterprises. So the way you can think about it is if you're a school, an office, a medical facility, anything, all you need to do is give us an address and a floor plan, and we handle everything from ISP procurement to deployment and operations to designing and manufacturing our own switches, access points, security appliances that we will install with our firmware, software, and ongoing management. So really putting the service part in as a service alongside everything else.
Thanks, Sean. So picking on that, right? So you build networks for enterprise.
Yes.
It is managed network. You manage it for them. You have a lot of enterprises across the world that you would like to build for, right?
Mm-hmm.
So it's a big task to manage so many enterprises.
Yeah.
So the proliferation or the growth or the area of AI ops is meant to really facilitate that, right? Can you talk a bit about how do you leverage, let's call it AI ops techniques, tools, to be able to help you to manage these networks and what you're trying to achieve out of it in terms of business outcomes, if you will, and what you've seen as gains in doing that as opposed to manual operations?
Yeah, it's a really, really good question. I think there's a few points to highlight here. So the first is that a lot of these products are only as useful as the system that they understand and can interact with, right? So for Meter, what was essential for us to do over the past decade is to actually have a fully integrated stack where anything we build can orchestrate everything across the access points, the security layer, ISP operations, all of that, right? So as a starting point, that's a very critical thing to think about, irrespective of any technology that you put on top of it. But I think the second thing is, looking at a lot of, say, the frontier models that are out there from OpenAI, Anthropic, things like that. What we found with our new product we've released recently, which I'm going to talk about in an hour, which is Meter Command. One advantage that we found that is really necessary to deliver a great experience is understanding the problem that IT and network engineers experience, which is one, they have immensely increasing demands on their time, right? So someone that was once managing 1 to 5 facilities is now managing 5 to 20 facilities. They may be shrinking teams as well, right? So you need to do a lot more with a lot less. And so when we built Meter Command, one of the things we looked at and measure very closely is just how much time can this save versus what it might have taken before. And little things like managing a support request about James in finance saying Zoom isn't connecting, right? With Meter Command, because it's trained on understanding our entire stack, what used to take 20, 30 minutes is now just one question our support team can pose to our product. And it will then do the work of going and talking to every piece of the back end, all of our architecture to compile a response that can then just do everything they would have done in that time anyway. So it's really about kind of marrying all that together and being able to deliver something that saves time at the end of the day.
So basically, it seems to me like you're converting what a person used to do, a human, with tribal knowledge to go to multiple systems, look at dashboards and so forth, to converting that to a natural language, if you will, question
Yes.
to say what's happening with Zoom.
Yeah.
And all the magic is happening behind the scenes to go and look at anomalies, gathering together and providing that information to the operations person to be able to root cause the analysis. And that's what's giving you the advantage.
Yep.
I think there is a lot in here to dig through, like what the techniques that get used and so forth to achieve that. I'm not sure the time will allow to do that, but we'll try to leverage whatever time we'll get probably after this, after we do the round on this. The important part is really to focus that these are working things that you have today. I think that enable you to achieve that objective, basically to solve the problem, root cause and remediate the problem in much better time than you used to have before. And that's really the power of AI ops. I think, Owen, you could talk to that as well in your environment, what you do.
Right. This is a very important point. If you think about cellular networks, these have been the purview of the AT&Ts, Verizons, and T-Mos of the world, and they had large staffs pull together the appropriate WAN equipment, the private cores or the public cores, along with nationwide services. Bringing that into the enterprise has proven to be a very, very hard job. So apart from putting together all of these things, on day one, we had to manually configure these systems. But we recently did a complete build out at MIT, one of the key buildings, 8 stories, multiple radios interfacing with the macro towers. And after going through the initial round with configuration, we used AI ML techniques to then do the day one configuration. And that brought down the implementation and configuration from matter of weeks to a matter of 4-5 hours. So that is the first step. Now that we did that and brought the configuration and troubleshooting down to a matter of hours, the next thing that we did is leveraging chat GP and all is to put in a human interface in front of the problem solvings and bring agents and all that stuff using chat GPT with agents and LLMs to go and leverage that piece. And the next thing that we're doing is take all of this agent software and RAG and all of that kind of stuff and roll those up into what we call AI teammates. And what an AI teammate does, there are cellular experts, there are RAN experts, there are packet core experts, there are front-haul network and security experts. We are rolling up these technologies so that all the stuff that we went through in tomorrow's world, these become co-pilots that are available to help different enterprises as they bring on private cellular clouds into their organizations to leverage these AI co-pilots to be able to run the system, much like that we took advantage of these capabilities. And we expect to see more and more of these co-pilots take on the job, speak the human language, and be able to assist our customers in bringing up technologies.
This is an important part. We'll come back to that actually, because I think one question that may pop in people's head, you have these things happening. How accurate are they? I mean, when somebody says there is an anomaly, I mean, usually in AI-related problem, we talk about accuracy, meaning either misdetection of an event or the false positive, right? and those could contribute to noise or contribute to missed things that could have happened that you should have noticed. Uh, do you see that? I think you mentioned Copilot, right? So you didn't mention autopilot, right?
Yeah.
But rather you mentioned Copilot. Could you talk about that a bit? Why you're doing Copilot rather than autopilot?
Yeah, that's a very important point. I chose the word co-pilot very carefully. I did not say pilot because today with the chat GPT and with some of the systems, there's still the outside chance that there'll be hallucinations or every once in a while the training sets are not good enough to able to deeply answer every question. So you got to be really careful in these early days that we don't overpromise and underdeliver. So today's state of AI and chat GPT and LMs is such that they do a great job, but trust but verify from a human perspective. Think of it complementing humans versus replacing humans because the technology is not at a point yet where it can guarantee the right outcome 100% of the time. So you got to be really careful to walk before we can run and use these pilots or use these as co-pilots, not as pilots, if you will.
Very good. Thank you. Raj, any insight into that? How do you use today AI techniques to help you operate your network and or assist your customers in detecting problems when they happen and remediate them?
Yeah, so if you think about Tata Communications, we have a very big network at this point of time. We carry around 60 billion minutes in a year. 1 in 3 packets from an internet perspective pass through our network, so you can understand the huge network that we have. So the first thing that we had to do for ourselves is that how do we do what Sean mentioned, right? Do more with less, and that's where AI ops came into our own operations first. While developing that, we found very good use cases that we can then take to our clients. And we have a model which we have developed at this point of time, which we call as New Automata. It's available for our clients at this point of time, which helps the clients to move from reactive to proactive to predictive to cognitive. Right, this is the journey that we take our clients through. And when you think about a reactive, this is where no correlation is happening, to proactive, where some kind of correlation is happening, and to the final stage is where what Alvin just mentioned is where you can take, or the AI can take decisions which may be deployed or may not be deployed. It may be a pilot or may not be pilot. Now, in Alvin's case, he's saying he's more using it as a co-pilot. We have developed a model where it's both a pilot and a co-pilot, depending on the severity or the priority in the level at which it falls, right? So, we are using both at this point of time.
So this is a trust. I guess when you trust what it comes up with, you could turn it to make an autonomous decision to
Yes.
take action rather than rely on people taking action.
Correct.
Jordan, but you.
Yes, we're leveraging IBM Cloud Pak for AI ops, and we most recently have implemented closed loop remediation for a number of events. So of course we're using some of the advanced event correlation, but now we're actually making topology changes. We're making metric changes. We're actually adding capacity automatically using runbooks, using that automation. That we're actually getting dynamic thresholds fed to us by the AI engine, using those thresholds to allow us to make decisions. Whether it means bouncing a route peer on our IX service exchange, or monitoring SLAs, jitter, loss, delay for our customer services, and making sure that we've got the correct amount of capacity to ensure there are no outages or no service interruptions, and making sure that customer is receiving exactly the service they expect. So we have manual intervention, but we also now have the closed loop remediation. And we're looking at, and we talk about these thresholds. I think if we were talking 10, 12 years ago, we'd be talking about predictive analytics. And we're calling it AI now, of course. But we might look at an optic, we might look at a transponder and say, I see 3 dB loss. But I know now, because I've monitored enough optics over time, that if I see that 3 dB loss over a certain period of time, I'm going to potentially have an outage. I should bring up another route and take that one down, schedule it for maintenance, take that optic out, take that transponder out, and make an automated decision about that to ensure that we've got the capacity in place for our customers as needed. So we're slowly phasing in this automated remediation, and so far so good, and we'll continue on the journey.
Very good, thanks. Yeah, these are important part. I think we all experience the same thing, actually, understand that there are a lot of techniques. And one thing that I caught up on what you said, whenever we say AI, I often, somebody used the term earlier, referred to it as augmented intelligence, co-pilot, basically assisting people to solve, but then you could relegate autonomous action if you want to. but it's not all about machine learning. There is expert rules that could be embedded in. I believe also, Sean, you mentioned earlier runbooks that are tribal knowledge that being embedded in that could be triggered based on some things that happen. Just to be allow the audience in here to ask any question. I do have a couple of points that I want to get back to, but before we run out of time, anybody has any question to the panelists or any thought? John? All right, so let me go back to something in here. I think the problem usually when you train something, you have to train it on a data set, right, to develop a good model. We've mentioned LLM a couple of times as a means to be able to interact with system, right? I mean, whenever you talk about natural language processing, you're talking about language models, large language model often is the case. How do you find, what have you done in your work to be able to improve the accuracy of these models in the domain that you're talking about? Because usually these models, to be accurate, they have the more trained on relevant data set to the problem that you are solving, the more accurate you are. So can you talk about like what is your process? Do you use Chat GPT, you use Llama out there, or do you take it and train it better on your corpus, if you will, of data to produce better accuracy? Sean, you want to take that on?
Yeah. So we spend a ton of time figuring out how to leverage the best techniques and models for meter command. And as a first principle, we don't train on customer data. We felt that was incredibly important, just in terms of respect for our customers and the relationship we have with them. But we also tested a lot of the frontier models from OpenAI, Anthropic, Mistral, etc., just as a baseline for understanding how they perform on networking tests. And so it just wasn't good enough for networking tests, right? It was one, inaccurate, but two, also slow. And that led us to train our own models based on our own software architecture, how we built our devices, all of that. And so instead of training on customer data, we actually train on synthetic training runs based on everything we have in our APIs and our systems. And so what that's resulted in for us is a smaller model that is much, much faster than a ChatGPT or a Claude. I think we benchmark on every model update, and we won't accept anything that's less than 2 to 3 times faster than those.
Is it faster is only the measure or the accuracy as well? Do you measure?
Yeah,
accuracy?
the second thing is also an accuracy. We also did at least 2 to 3 times accurate. If there's any sort of regression in the model, then we'll go back and we won't release it.
Very good.
And a lot of it is because the models are focused squarely on networking and meter in particular. And so that allows us to have something that is much narrower in focus. And it has the side benefit of reducing a lot of things like hallucinations and so on and so forth. If you were to go to meter command and ask it about Michael Jordan's 1993 season, it's just going to say, I don't know what you're talking about.
Well, at least it's not hallucinating. Go.
Yeah.
All right. Owen?
Yeah, from our perspective, we also went through a same journey, started with the Chat GPT, started with the language models, and tried to apply that directly. Then we tried to map it onto SQL-based commands. That turned out to be not so effective at all. Ultimately, what we ended up doing is complement the LLMs with our own DSLs, our domain-specific languages for the work that we had at hand, and applied and started with our own training sets, with our own tribal knowledge, attached to a DSL, and we came up with that tribal knowledge databases and data models for the networking, the security, cellular technology, brought them up and put them into RAGs and things like that for the agent stuff work. So complementing the LLM with a RAG that's specific to your domain and applicable to your own environments, I think is a necessary step. It's not like you can take an LLM and it's great for natural language processing and removing the language barriers and converting to easily conveyable human language, but it's not necessarily the best for a domain-specific knowledge like your networks and discerning what's the problem, fault isolation. And that is, I think, what's going to happen. We'll go through a wave of tribal knowledge being built in, and over time that might also make its way into the open source form, but it's not quite there yet. So you have to complement generic LLMs with domain-specific RAGs and things like that.
Raj, any insight into this?
Yeah. So I'd actually look at it in two different angles per se, right? So one is from an ops perspective of what's happening, how can we do it better? There, obviously, we have a whole lot of data, and therefore we use our own data sets. But then you'll have to also look at it from a future perspective, right? So one of the things that we did is that there's a ticketing company that I'm sure all of you use, or most of the companies use. What it does is it opens tickets when things go wrong in your network or whatever, right? And then a human being comes in who takes an action. Now, can there be a flow where the ticket generated is understood by an AI engine which says, if this happens, do this, and then the network changes on its own? Now, that's the future, correct? I'll give you a classic example out here. I was talking about this afternoon itself. This this location may get like 50 visitors in a normal day. Today it has maybe 1,000 visitors, right? So the internet sucks out here right now, correct? So now, if the AI engine understood that and said, okay, we have X bandwidth for 50 users, can it shift to X into 50 for the given day or 2 days or 3 days without a human coming into picture? That's the next level of evolution that we're talking about from an ops perspective, right? And there are a whole lot of use cases that you can do. This is just an example, whether from a manufacturing flow perspective, whether from an office flow perspective, and so on and so forth. So if you look at these two models, it has to be tackled in a different manner, because in the first model, you'll have the knowledge, you'll have the run books, you'll have the tribal knowledge, you'll have the all that kind of data per se. For the next one, you will not, and there you will build, from the
Now,
models that are already there.
generative in a way, right?
Yes.
If I may, Raj, and not to be rhetorical, but can't we do that today? I mean, if these APs all of a sudden go from seeing 10, 50 max show up and all of a sudden 1,000 pop in, I don't know, if they're running Google Fiber, why can't this dynamically, just as an example, probably using a service provider, why can't they turn the dial on that capacity today?
We are doing it for customers
Oh,
now.
okay, exactly. So that's perfect to fix the wireless issue. To turn the dial.
We are doing it to customers on a beta at this point of time. Let me be also
no, fair enough.
Because we've just kind of done a POC on this. We've started doing beta on this. It has to be taken to the next level, right? Because it has, obviously, when you're running a large provider architecture, there are a lot of components in between, and the last component being the OSS BSS, correct?
Yes.
That's where things become a bit complicated for the service provider.
The operationalization. Right? That's the long pole in the tent, if you will.
Exactly.
But it's like the tech is there today, right? And it's actually fairly simple. We can make those changes. It's real. We just got to get there.
Right. I think the challenge that when you automate, you want to make challenge. You want to make the change with stability in mind, not to cause chaos. With the
Exactly.
Right?
Well said.
So this is like the plan has to be well tested and executed to be confident in what you're implementing. I think that's the key. I think what I want to do that. Anything, Jordan, you want to add to this further?
No, I just say I think it's so interesting. And we talked about my time at Sienna and orchestration. What we talked about 10, 12 years ago. I mean, we've been talking about this for a long time, and I think we're finally starting to get there. And the realization, the instantiation of some of these things. I mean, I remember talking about watching news feeds and a natural disaster. We know of an FOMC meeting happening. Trading volumes are going to go through the roof. Turning the dial on that capacity and allowing those platforms to operate the way they need to, as they need to, and have the capacity needed, and then take it back down so it's cost efficient. So, anyway, it's nice to see us make progress in these places.
So, I think we'll open up. We have a couple of minutes. We're allowed to go a few minutes beyond. That's what we're told. So we'll open up again. But I want to summarize the big takeaways from the AI ops part. I think for people who have not been implementing this, they think it is basically imagination. Basically, that we're not there. I think obviously the area is still evolving. It's not like fully developed, as you heard. There is a trust issue at some point because accuracy probably will never be 100%. The question, though, that is really the value right now that we're leveraging tools to process a high cardinality problem. What I mean by high cardinality is that we have a lot of signals being emitted from systems, applications, and the system could be networks or end system running the applications. And you're processing that in real time, as many said. You're detecting anomalies, and then at least when you ask the question, what's happening, that data is being presented to you, basically pulled in with relevancy to the problem that you are seeing. And that by itself at that stage, what we heard from Sean, from Alwyn, from Raj, as well as from Jordan, is enable operations to home into the root cause of the problem faster, and therefore to trigger remediation. And remediation could happen in two ways. That's where the large language model come in. Is that first you're understanding the human interaction to say what problem you're trying to solve and retrieving the data. But more important, there is a retrieval part that both Alwyn and Sean talked about, is retrieving the right runbook for the user to run, even if they run it manually. Now, if it is a runbook, you can trigger the implementation, and that's where the closed loop control comes into picture when we talk about programmer network to try to make the programmer to interact, being for bandwidth, being for changing configurations, protocols, links, or whatever it is to remediate the problem. So there is a human executing, and as you gain trust, you could relegate to the system to execute that changes to remediate the problem, and that's important. The other part, I think, which I like to see in the industry, today there are large language models being trained on the worldwide wealth of information that exists there. That's very large, and they have a degree of accuracy. What we heard also from Sean and Alwyn in particular in this case, is that they trained these models, or they put base models and they trained it on that particular domain, which is networking. With that, they improved the accuracy of the model to really have better accuracy understanding the questions or retrieving the data. And that's key. We wish that we get to the point where we could make those network specific language models to be available in the industry as open models that exist in other space today. We're not quite there, but maybe some people sometimes feel this is proprietary information that adds value to their companies, but hopefully will evolve in that direction where the wider community could take care of it, could take really advantage of that, right? I think we could get to that point. Any questions related to that? Because we'll come back to the WAN part if there is, and we'll close with that. Scott.
Are there any efforts today that you're aware of to accomplish that, right? Where you guys all come together to come up with a mechanism or like an open standard for like AI ops in the network world?
Um, Anybody wants to take it? Because I could talk to that a little bit. So I could. All right.
You're
So-
on, brother.
Okay, cool. So there is a desire. There is discussion going on, at least in some forum. I'm not trying to create something. I don't know if it will or not, but there is desire to do that. And I think when we say you have to be specific about what problems you're trying to solve for industry. So I'll give my 2 cents on this, right? I may be wrong, I may be right, all right? But I'll tell you my 2 cents on this. I think it's very hard to pick out of the box tool to make it to say this is open source that solve anybody problem, because the base problem that you get is the data problem. And the data is enterprise unique, if you want to put that, well, service provider unique. And that involves two things, the quality of the data that you get and the metadata associated with it, right? So you have to solve that problem irrespective of what. Now, if you want to leverage systems that can process that data, let's say they've come from open source, from vendors, or whatever it is, it will be nice to have a given format in which you standardize on how that data will be. Is it going to be JSON? What kind of metadata? What is basically the keys that you want to use for that metadata, so that it eases the onboarding of that metadata on whatever machine learning platform you want it to get into place, so that you don't have that upfront burden, if you will, to onboard your case on the top of that platform. So that will be a good use case. Again, this is a desire if we could standardize on that. The second part, and I know standardization obviously is a long journey sometimes, but at least you get yourself on that. The other part is the LLMs. I'm not aware of that. I know also there is some talk among few people that I know of. I'm sure there are other buckets talking about that, to try to really do something in that space as well, so that you could leverage network domain specific language models for the problem that we talked about. How that will manifest or how that will develop, I really don't know. But I know there have been discussions among a group of people in this space.
Yeah, one thing I'll add there, if I look at it from an enterprise perspective, vendors probably may not be the first ones to jump on this, but many enterprises, if you think about what's the holy grail with AI, it's reduction of events and logs. Because if you think about most network engineers, they are reacting to events, some failure, and going and reacting to that. But I'm beginning to see many customers beginning to talk about, can we just extract all these logs and put them into an LLM model and look at the training data? I think integrators like the Tatas of the world, Deloittes of the world, and folks like that who are cross-vendor at big companies and all that have the best probably vantage point to be taking all this data and cut down the number of logs. We've seen some customers specific to their domain reduce the number of events very drastically, and I think that's the ultimate goal. And I suspect that this is something that's a cross-cutting concern. All enterprises should share that information enough after anonymizing, removing the IP or removing any intellectual data specific, and creating and open sourcing some of these models so that we can create a language model for
ecosystem.
networking and security events.
100%.
Yeah.
Very good. And security is another part. We talked today about network operations. We didn't talk really much about security. Again, we don't want to open a can of worm, but you could imagine actually what you could do at that area. Anybody else has any question?
Yeah, Nabil, when it comes from Bluebird perspective, where do you see as far as AI adoption on your side, as far as managing the network and architecture? Is there an open embrace that are you still looking to hold off a little bit on that as you communicate the different types of news around the world?
Yeah. So we're talking about network operations in particular, right? So I mean,
Sorry,
I think,
Dan, thank you for that because he, told us do not ask this question.
yeah, exactly. Yeah. I think.
Next time, give me the questions in advance.
All right, no problem. I mean, the reason because
The
I'm
question's
coordinating,
not
I'm
to
not
ask.
the panelist, right? But I'll give the kind of the courtesy to answer. I hope you didn't embed that too, but that's okay. So that the thing is that I think I would say it more generically. I think any enterprise that wants to stay at the top of the game, technologies evolve, life moves on, right? I mean, this not today. AI, these are tools that at your hand. I think anybody that wants to do better has to leverage the tools that are being presented, right? So it behooves us to really look at the tools, make sure that how they apply, what the data that needs to be, how it needs to be prepared to be ingested with them, and prove the value. And I think when you prove the value, then integration into operations become easier. To throw something in the middle of things, okay, it's AI, okay, it's probably very appealing these days to attach AI to anything, and somehow it finds some traction. But that doesn't mean that it proves business value. And in the business value in here, what it means to business outcome, to network operations in particular case. But yes, we are interested in that, and we're obviously looking at that. I mean, I could say that, but I cannot say more than that. All right, so I think anybody else has any question? I want to come back, wrap up though, because we've spent a lot of time on AI ops. I want to remind people of where we started as well. I think the important part that's highlighted in here, if you go today to, you deal with AI in general, training, inference, all this stuff, often is about the technologies that fit within the data center to enable GPUs to collaborate on building a model, right? That's all the network. Ultra Ethernet is being built in that space. The ultra accelerator link, or the kind of equivalent of NVL that was developed by, as you know, by the big GPU company, right? NVIDIA is used to scale up within the chassis and so forth. What you heard today, the applicability of the WAN to that space. And this is related mainly to moving data in and out, whether training data or models, to place them at the right place, as Jordan and Raj had talked about, or to be able to place them at the right inference point, as also Alwan talked about, or to connect users to get good user experience by placing those models or direct them with quality to the right inference point to get the response as fast as possible. Attributes of all that interaction across the WAN or the LAN connected to the WAN are the three attributes that we talk about always: is reliability, right? Loss, which is to contribute to reliability, as well as the latency that people are catering for. And please keep that in mind. So there is WAN facilitating connectivity to AI endpoints, as well as there is IOPS part. Anybody has concluding remark further than that? All right. Well, thank you for participating in the session. Hopefully that was useful.
Thank you.
Thank you for moderating, Nabil. Much appreciated.
Thank you.
Thank you, Nabil.